I've been getting more and more into vintage electronics displays recently, and I thought I'd make a project using Nixie tubes. The most useful thing I thought of? A clock. I planned this all in my head, but it's not completely thought out yet. But I think it would be cool if the Nixie tubes were on top of a box, and on the front of the box would be a Kumiko panel. After rough milling my strips down to size, I could take them down to final thickness using my thicknessing jig. Then, using this 30-degree sled that I saw Mike Farrington use, I could cut the lap joints to make the frame. To make all the various angles on the infill pieces, I made a series of shooting blocks that I can use with a hand plane or a chisel to slowly shoot down those ends at the right angle and slowly to the right length with the built-in depth stops. Some may say it's sacrilege, but I'm adding a dab of glue as I assemble the frame and the infill pieces. After trimming off the excess on the bandsaw, I barbarically flushed everything up on the edge sander. You know, for my first attempt at making Kumiko, I think I have a usable piece. Next, I am going to use this piece of curly maple to make a box that will go around the Kumiko panel. Now, if you've never worked with curly maple before or hard maple in general, it's not very fun. After a quick pass over the jointer, I decided to change my mind and build a really small river table. But then I realized I didn't know how much time it would take for the epoxy to cure, and then I remembered I still needed a clock to figure that out, so I'm back to plan A. After scraping off the excess epoxy, I could proceed to mill it down to final dimension. I couldn't use my planer or jointer for this because I couldn't get it so that it didn't tear out. Therefore, it's the old Renaissance way. I decided I'd use miters for the box joinery and that I'd cut them on the router table. To do that, I had to glue on some temporary hardboard for the router bit bearing to ride against. Unfortunately, I don't think my router is fully trammed vertical in my router table, so I had to go back and adjust the miters with the block plane. I used a box joint blade to create a rabbet on the inside front of the box for the Kumiko panel to recess into. The Nixie tubes sit within a socket that has to be mounted underneath the top of the box, but because of the thickness of the box, I have to create these recesses for the sockets to sit within. I had a last-minute thought to make the Kumiko panel appear as if it's floating on the front of the box. I did this by making another rabbet within the first rabbet. I'm really glad I decided to go through with the second rabbet because I really like the way the floating look turned out. And you know what else I like? This video. Because I clicked like down there. And yes, you can like your own videos, and you should click like too, to feed into my own vanity. And while you're at it, you may as well hit the subscribe button. Before I glue up the box, I'm going to pause and start working on the electronics that will go inside. I want to make sure everything will fit, and I probably should have figured this out before. Welcome to my office, where I want to show you how this clock is actually going to tick. You may have heard of an Arduino, which is a board like this one that contains a microcontroller and a bunch of other components that I really don't need for this project. Therefore, the logical choice is just to simply use the microcontroller by itself and assemble a board with only the components that I need. I chose to use this PIC16F886 8-bit microcontroller. It has 24 ins and outs and a whopping 8 kilobytes of program memory, but that is more than enough for my needs. This is a prototype of the clock I'm going to make, and I made it on a breadboard so I can make sure that my idea is going to work. Even though the PIC has a built-in clock, it's not accurate enough to keep time over a long period, so therefore I'm using this external quartz crystal so it will do the job much better. So let's talk about my goal here. This is a Nixie tube, and I want 4 of these to display the time. Now in each Nixie tube, if you look real close, you can see that there are 10 different elements or 10 different cathodes on the inside, and they each are in the shape of a number, 0 through 9. Now one method of doing this would be to output binary from the microcontroller and convert it into something that the Nixie tube can understand. So the way I have prototyped this clock is to display each 4-bit binary number in its own color, so we can read 4 different digits, the 2-hour digits, and the 2-minute digits. So when I program the microcontroller to turn on, it will initially display 12 o'clock, as most clock radios do when you turn them on. And as you can see here, our first hour in amber here is a 1 in binary, and our second hour, or least significant hour I should say, is displaying a 2. So we have 1, 2, or 12. So 12 something, and in this case it's 00, so 12 o'clock. So additionally, there are going to be 4 switches, or 2 of these double momentary switches, that are going to connect to 4 of the inputs, and they control the time. This one is wired into the minutes right now, so I can increase the minutes like such. So now it reads 12:01, 2, 3, 4, 5, and likewise I can also decrease the minutes by going the other way, 4, 3, 2, 1, 0. Like I said before, I won't be using these LEDs in the final project, but each 4-bit digit will be sent to a Nixie tube. But since the Nixie tube doesn't display binary, the 4-bit binary needs to be decoded into something the Nixie tube can understand, which is where this old Soviet integrated circuit is useful. All these really contain is a series of logic gates that will output a DC signal to each cathode digit within the tube. The anode of a Nixie tube requires quite a high 170 volt DC potential for it to turn on, or fire as they say. The way I'll achieve that is by using this cheap converter that inputs 12 volts and outputs anywhere from 140 to 250 volts DC. So since that converter uses 12 volts as an input voltage, I want a way to convert 12 volts down to 5 volts for the microcontroller. And the way I'll do this is by using a voltage regulator such as this one. Now, I'm not going to show you all the details of the code because it's really boring and I don't want to lose your attention. I borrowed this code from Jens and his channel is called Friendly Wire. And I want to thank him because a lot of this project was based off of his binary clock build. And if you want to learn more about microcontrollers, I highly suggest you check out his channel because I learned a lot from there. Now that I've showed you the prototype and I verified that it works exactly how I want it to, I can go ahead and make it permanent by soldering it all down to one of these perf boards. I got started by laying out my ICs on my PCB and marking where the ground and VDD connections are going to be. Then I soldered down some decoupling capacitors for each IC. And after a bunch of DC and ground jumpers, I could start connecting the quartz crystal with its capacitors. I actually ground down some of the solder points on some of the capacitors where the ICs would sit over top of them. After soldering down some jumpers for the data connections, I could figure out where I was going to put the voltage regulator. Then I could solder down the socket for the microcontroller and then move on to all the decoders. Here's a socket for the Nixie tube that I mentioned a while back. I first have to solder on a current limiting resistor on the anode, and then I can proceed to connect a bunch of jumpers for the cathodes. Let's see if it works. Huh. Yeah, I actually missed like 3 or 4 ground connections. Let's try it again. You didn't actually think I was going to spoil the big surprise, did you? You're going to have to wait till the end to see the big reveal. Now I'm going to get back to the box and glue it up. I get started by laying down some glue to size the joint, as they say, and then I forgot that I was supposed to mask off the inside corners. You missed one. Now, painter's tape should be all that's necessary to clamp down these corners, but I have control issues, so I grab my band clamps and squeeze the daylights out of it. 3 days later, I took the band clamps off the box, not because that's how long the glue takes to dry, but because that's how little time I get in my shop. When I initially ripped down the stock of the table saw, I was left with a little bit of chip out on the edge, but I left it purposefully wide so I can bring down my final depth on the edge sander after I glued the box together. Looking good, Billy Ray. I needed some way to mount a back panel so that I could access the electronics if need be, so I used some leftover maple and made these little nubbins. Now that the box is all together, it's time for everyone's favorite part, the finish. I'm using a water-based dye for the color, and I mixed together some red and brown pigments until I came up with a color that I liked, and I did that by using a bunch of different test samples. After each coat, I sanded back to almost bare wood with 220 grit, and I did this a total of 3 times. I then sprayed 3 coats of shellac on the box before I started sanding between each coat with 400 grit. After a total of 6 coats of shellac, I sanded up to 1200 grit, and then I put on a coat of wax and polished it. Since the finish is finished, I need to make a back panel where I can mount the switches and a power connector. I decided I'd use some of the leftover acrylic I used for my video about making a table saw overhead guard. At the drill press, I could drill some holes to mount the panel to the box, and I could drill some holes to mount the switches and connector to the panel. I love how this turned out. It's pretty much exactly as I imagined it. I really like how the reddish-brown dye complements the orangey glow of the Nixie tubes. I like how the Kumiko panel mostly obstructs the electronics inside, unless you're looking at it from the right angle. I really like how solid these toggle switches feel. They're not particularly expensive ones, but they sure feel a lot better than plastic push buttons. Incorporating electronics into woodworking thoughtfully can add a whole new dimension of functionality and even aesthetics to your woodworking projects. So the great thing about being a woodworker is that we can take a prototype on a breadboard and see it all the way through to a completed, finished product at such a level that it could fit into a home's decor. My Kumiko Nixie clock is something that I'll use every day, and I will cherish it for a long time. I have loads of ideas for integrating microcontrollers into projects for inside and outside the workshop that I'll get into in the future. Don't forget to like and subscribe so I can get validation from people I don't know on the internet. Thanks for watching.